Perfect. We are live. Good morning for our first episode of Coffee and Compressed Air. We're looking to make this a quick, easy, educational, but also a little bit more laid back way to learn about compressed air, some of the issues that we see out there in the world, and how we can just all work together to make it a better place. So I will let Elvira go ahead and take over because we want to keep these in a 20 minutes. So it's a very quick coffee break. And then everybody can get back to their scheduled routines.
Perfect. Yes. So hi, everyone. So for someone, it's morning. For some, it's afternoon. So for me, it's an afternoon. And again, it's not a webinar. It's not a workshop. It's just to say hi to our compressed air community people here. So feel free just to put your comments. And I think in the future, also would like to have you with us here on the LinkedIn Live. Anyone who has anything to share in 20 minutes would be great. Today we announced a struggle that usually compressed air systems struggling, but especially operations and in facilities. And as an engineer walking through the facility, we also struggle with that. You come to the machine end point of use where our compressed air is finally reaches and there is no pressure and operators are complaining. Where is the pressure? There is no pressure. And here today, I just wanted to share with you my personal experience and approach that I usually use to help and to explain, first of all, people in the facility why there is no pressure and how it can be solved, because it cannot be necessarily solved that there is a problem with the compressor room, but it can be just some small fixes. So I would say it's more like the conflict management on how to just tell people, don't worry, everything is fine, the pressure can come. Because very often they don't even need the pressure, so they need the flow. And this is another thing. But because we talk about the compressed air, there is the first sensation that we have, where is my pressure? And I need pressure. So I want to share with you, let me just share my screen, few applications that you probably also see that. So you can see my screen now, right?
No, I don't see it yet. Let me see.
I think it's coming. Sorry. So can you see it now? So basically, Danny, can you see it? I think that there is some delay.
Yes, there is a delay because I'm looking live. So.
You're looking live. There is always delay. So anyway, so I'm sharing now my screen. And basically, so when you have the problems with when the operators say there is no pressure, where it can be. Here, I show you just a few application of the recent projects also that I've done during the walkthrough in the factory. And this is basically some things that you can see. So the first thing is usually some standard blowing applications. So I'm going to try also to play a video here. And there is a rail with the drilled holes. And this rail is basically supposed to blow and to clean the boards that you see there, the boards that were cut. And the operator saying there is not enough pressure. So what it can mean? It can mean that there is not enough blowing force the board to clean. So meaning that the quality of product is not good. At the end, the cleaning is not quite well done. So then there is, for example, here it's one of my favorite. They had before engineering nozzles. So the same operation. So they even installed some pulse blowing here. And they removed the engineered nozzles that they installed before. So this is already another facility, for example. So they removed this engineering nozzles, and basically they had to. They said also there is not. We removed it because there is not enough pressure. So it doesn't necessarily happen only with the blowing applications, but one of the very important is also cylinders. So in this case, the cylinder is doing the pressing. So yes, and when you see when the carton board is passing and it is doing the stamp there, not enough pressure, maybe not so critical, but sometimes when it's critical applications where you have to put together or to clay together packaging, for example, or any other stuff, it's not for cylinder applications. If it's not so critical as press, not enough pressure can mean that machine has a set pressure of 90 psi or 6.5 bar, for example, 7 bar. And the producer of machine actually installed the pressure sensor that is alarming if the pressure goes below this pressure set. The same thing here. Here you see a very lonely cylinder that just goes up and down. So just adjust it like the piece that is passing with a super long tube. And I think this kind of stuff we also can discuss maybe on the next coffee break, where actually the consumption is going, where the problem is. So the thing here is that not enough pressure. Also can be that there is not enough, that the machine is alarming, or maybe the quality at the end of the product is not good. So this is things that I see quite often that are happening with the fact that there is not enough pressure, or pressure is not going. And here we need to understand why it's actually happening, right? So the most obvious thing is that, yes, something is wrong with the application. And then the next step that we need to check, even before any sophisticated monitoring systems, so we just need to go in front of the endpoint of use, look for the closed pressure regulator, and just see what is when this application starts to blow, what happens in the pressure regulator. And the arrow on the manometer that you can see, if it is a mechanical manometer, will just drop and go back. So meaning that there is the certain pressure drop while this is happening. So I can post later videos like that, so I have it. But in general, why this is happening, we can see in the here. I'm going to share you this thing. You can see here. So the logic, so I'm sharing now just a few information already for the calculations. And we can explain also operators where is the problem and why it's actually happening. So not enough pressure when I'm going now into the flow, meaning that there is a pressure drop somewhere. So if we need a 4 bar at the application and the compressor room has 7 bar, and there is not enough pressure, so it means something is wrong actually in the distribution line. So in the distribution line, or very often, some problems also can occur exactly at the application. And since I come from the pneumatics and from the end point of use of compressed air, because each compressed air system is a demand-driven compressed air system, so the application will always check what actually we need at the end of the use. So here I show you a very simple schematic of the nozzle that you just saw. So we have some blown application with the nozzle. So we have the valve, the tube, and the pressure source. Exactly this pressure source, of course, not a compressor, so because it will be very long to see, but it is a regulator manometer exactly before this application. And actually during the walkthrough of the factory, we really can identify what is happening and where is it. So we need to set the required pressure that we need here. Usually it can be a blowing force. Here you can see the very simple model of the nozzle. Again, nozzle, tube, pressure source. So for example, we require a certain blowing force, and then we can check if we lose anywhere here pressure. And for example, we set the required pressure or required blowing force, and then we see what are the pressure drops for one sizing of the pipe, for example, and for the one sizing of the pipe. So here you see an example. I have a required pressure here that depends also on that is associated with a certain blowing force. And then I reverse back the calculation. So I come from the demand, from the point of use, and I see what is the required pressure that I need here. So the science is very simple. So again, I don't analyze it from the compressor and see what is happening at the end. I'm actually analyzing what I need at the end. If the operator said there is not enough force here, I need to see what I need as a force, as a requirement, and then I reverse it back. So I need, for example, here this certain blowing force. And then in this application, I have the pipe. So the force has to be 5.5 bar. And here I have 2 pipes of diameter, for example, of 4 millimeters. And in order to supply 5.5 bar at the end point of use, for this, I need to have a 6.8 bar at the beginning of my system, at the regulator. And this is what in the practice I usually see, right? I look at the manometer, a manometer shows me once this nozzle starts to blow, I can see that it drops by 1 bar, for example, 1.2 bar while it blows, showing me that I have here the pressure drops. And here I can easily understand why it is so. And you can find many articles why the pressure drop can happen, but the only physical explanation of the pressure drop is that we have a restrictive component. So we have a component that is too small to give the full flow through it until the end of use. And this is the beauty of compressor system, because everything will depend on the end point of use. So it's not electric, so we cannot regulate it. So it depends on what size of the nozzle we put here, or open blowing, or any other. It will basically just suck the compressed air, and it will cause the pressure drops in our system. So the flow will go in this direction into the ambient. And here in this case, you see that the problems with quite high pressure drop is my restrictive components. And in this case, the pipes are too small. And of course, when you have the whole system, it starts to add up, and then we can have a really high pressure drops, and then we need to regulate it at the level of the compressor, and it starts to be really complicated to understand where the issue is. But if we start just from the point of use and analyze the point of use quickly, then we can understand if we have any problems in the distribution and so on. And here we have very simple example. Then in this case, the minimum pipe diameter has to be 4.8 bar, because the pressure drop here is 0.6. And I ask that I want the pressure drop not higher than 0.3 bar. In this case, I can understand, okay, I need at least 4.8 bar. And here I already changed my pipes. And here, for example, I put 6 millimeters internal diameter. And as you can see, I could solve the pressure drop problems that now I need to have, not in order to reach here 5.5. Here I need to supply 5.7 bar. So for all our users from the US, if it is a coffee break for you, so you can also see, so here, in order to have here 80 psi, I need to have 83 here. And here, in order to have 80 psi, I need to have a 99 psi at my supply. And usually, so I took here one example. So this is a standard that you can find, I think it's one of the German recommendations, German standards, but we also have it in a different national levels, but this is best practice. So meaning, what is the ideal pressure drop will be in comparison with my demand. So basically for distribution line, for connection line, and for connection accessories. So 0.3 bar, it's for accessories, so meaning for the larger connections. And then you have a connection and distribution line that must be really low. Of course, you cannot have a pressure drop 0, so it's physically impossible, but it has to be at least 0.03 bar, already quite small, in order to run the system on the optimal level. But what I usually really find out from my side, what is very useful, is to have this, to keep it, start small, look at the application. So usually I always talk to operators and ask what is actually really happening. And sometimes they need, especially in the blow-in applications, they don't need a high blow-in force, but they need a high volume. So they need the high flow rate in order to clean some surface. So in this case, we need to have the components that actually you can work on the lower pressure, but with a high volume. Or we can work on the high pressure, but with the lower volume. So there is always opportunity to optimize it, and there is always opportunity to reduce the pressure level. The problem is solved on the demand side, on the end point of use. Then we already can go into the distribution and see how we can reduce the pressure drops here. But anyway, it's always start small, always start from the end point of use rather than in the compressor room, because compressor room, it's very simple. Just go there, you see there is a set pressure, and then ask the operators what's the real problem. Well, it's 17 minutes, Dani.
That was really good. I know between the two of us, we could probably talk about this all day, because I came from the blowing application world. So even though we collected all the data, but we would change something to optimize the blowgun or the air knife, and then it wouldn't work, even though on paper it said it would work. I didn't even know where to start looking. The main thing I would look for, I guess, would just ask, what pipe sizes do you have? But what would you recommend to like me 5 years ago when I'm walking in trying to optimize these blowguns, and I didn't really have that deep knowledge of the other parts in between that could cause the problem?
So I think the first thing that I usually start is to understand what is the pressure at the entry of the blowing gun. So usually there is always pressure regulators and manometers. So you always can find somewhere the closest one. And then just to see, of course, it's usually set. So you can even turn and look at the maximum one. So what is the maximum pressure that reaches there? And if you see, for example, the pressure that reaches there is really 90 psi and my compressor room is in 195, then it's fine. It means that there is no problem into the distribution. So meaning that it's already arriving the pressure that is required for the application. And then this is the first step, because in this case you understand if it is correlated to the compressor room. If it doesn't arrive, means that you need to go to that part. So we isolate the first part, and it's really super simple. Again, we don't need to install, measure 300 million things and buy super expensive monitoring system. The operators, they usually know what they have. So it's enough just like to have a walkthrough talk, put the pressure regulator on the maximum and see what is the maximum you see on the manometer. This is the first thing. Okay. Then when you identified what is the maximum pressure arrives there, once the starts to work, so you open the blowing gun, you see again in the manometer and you see the arrow on the manometer. And then you see what is once you press it, how the error behaves. And then you will see like this, call it, not shaking, but kind of dropping, right?
Yeah.
And you can see this delta, basically what is the maximum span of this. And for example, you have here 7 bar, you open the blowing gun and you see that it went to 5.5. It means that you have a 1.5 bar pressure drop between this part, between your blowing gun and your pressure regulator. And this is usually quite a short distance there. Yes, of course, if you also look in the machine, any packaging machine, you still can see. And then you go back to your blowing gun and point of views, and you see what is the pipe comes there. And then you just do the quick calculations as I showed you. Does this pipe fit? If this pipe fit, it's fine. So you either do the calculations or there already you need to understand maybe a little bit measurement, because the pipe can be also stuck inside. First, you do the calculation to understand if it's not too small. If everything is fine, but there is still already something's going on, then maybe you go and see if the pipe is too rusty, if there are like it's broken, there's already any mechanical damages, or maybe something already too old and something. But if you see that the pipe is already on the limit in terms of the physical calculation, then you see, okay, the pipe is on the limit, and then you check the connections. And usually there is some quick coupling connectors that will cause this pressure drop. But another beauty of that is that very often I see applications where the operator have already low pressure and it works fine.
Yeah.
And then this, of course, they already can go and optimize it further. So, yeah.
Thank you. Well, we went over a tiny bit, and I'm assuming people have to get back to work. So we will go ahead and end this one now. We will be doing this weekly, covering different topics. So feel free just to DM one of us if you have any ideas or questions or something you would like covered. We'll try to announce the next topic a couple days before, so that way if it's something particularly interesting for you, you can go ahead and add it to your calendar. Well, thanks everyone, and we will see you all later.
Thanks everyone. Have a nice day and evening.